Hello everyone, myself Shivangi, and today I'm here to tell you all about types of friction and their coefficient. There are basically three types of friction: static friction, limiting friction, and kinetic friction. Again, there are two subdivisions of kinetic friction. They are sliding friction and rolling friction. Now, let us know about each of them in detail. First of all, static friction. What thing do you see in common in all these pictures? Yes, all these objects are at rest and are not moving. Now, let us say that if we want to move the stationary table here and the table is really heavy, what happens when we give it an initial push? Yes, you are correct. Nothing happens. There is no movement. The table does not move even though we keep pushing it with greater and greater force. Why do you think the table does not move at all? The answer is the presence of static friction. The force that we applied is being balanced by another opposing frictional force. This force is nothing but the static friction. It is a self adjusting force. As you increase your force of push, the force of static friction increases too, and the forces are being balanced still. Now, I know what you might be wondering eventually. The table starts to move. What happens to the static friction then? Let us discuss this with the help of a graph. We assume that the force we applied is a horizontal force represented by the x axis, and the frictional force applied by the flow is represented by the y axis. Now, as we increase the horizontal force we applied, the frictional force is also increasing at the same time to keep the table at rest. Then, this continues to happen until the sofa starts moving, and that is when the static friction ends and the sliding friction begins. The sliding friction is more or less constant if you notice. This part of the graph, which is represented in yellow, is static friction. It's when the table is not moving in spite of the force we are applying. And this part of the graph, which is represented by red, is sliding or kinetic friction when the table begins to move. The point when the table just begins to move is called the breakaway point. Is there anything else you observed in this graph? Why is this line at a lower level represented at red than the maximum static friction force? The reason is quite simple. If you have ever pushed any heavy object, you would have realized that pushing it is a little easier when it's in motion. Yes, it is because the sliding friction is lesser than the static friction. That was the concept of static friction. Now let us arrive at limiting friction. Limiting friction is the maximum opposing force that comes into play when one body is just at the verge of moving over the surface of the other body, just as you can see in the picture alongside. After that, we have kinetic friction with us. Observe these pictures carefully. What do you have in common? The common speciality of all these motions are these types of friction can be classified as sliding motion. So, objects are sliding over the surface of another object. At this time, the opposite force experienced by the objects due to the surface can be called as sliding friction. So, sliding friction is a friction that occurs when solid surfaces slide over one another. We can see many examples around us, such as the friction between the pencil point and paper is an example of sliding friction. When we comb our hair the, or move the comb along our hair, the surface of the comb and the strands of hair also indicate the presence of sliding friction. Now, let us come to kinetic friction in rolling friction. Now, by observing the pictures, what do you think they are having in common? Yes, they are having a wheel or a spherical or cylindrical surface below them. So, when these spheres or the wheels are moving, their type of motion is rolling motion. So, the friction experienced between surfaces in motion in which one surface rolls over the other is called rolling. Now let us watch an activity to determine static, limiting and kinetic friction. For example, I have a bundle of books here with me and I want to push them. As you can see, pushing them initially was a little bit harder. This indicates static friction here. And the moment when I start pushing them and they are in motion, it becomes easier for me to push them. This indicates limiting friction. And now, when I take some sketch pens which are cylindrical in shape and put the bundle of books over them and then start pushing them, it becomes much more easier for me to move them. So, this indicates kinetic friction. Now, let us move to coefficient of friction. What is coefficient of friction? Coefficient of friction is the measure of the amount of interaction or the amount of friction existing between two surfaces in contact when they slide over one another, when one body rolls over another, and as two surfaces in contact which are not moving are acted upon by forces in opposite directions. Now, how do we symbolize or represent the coefficient of friction? The coefficient of friction is usually symbolized by the Greek letter mu, which looks like the one attached in the picture alongside. Now, the types of friction coefficient can be broadly classified into static friction coefficient and kinetic friction coefficient. Let us groove in to kinetic friction coefficient. As said before, kinetic friction is the amount of retarding force between two objects moving relative to each other. So, this is very much important in understanding the coefficient of kinetic friction, which is the proportion we get when we take the pulling force needed to keep an object moving and divide that by the force holding the two sliding surfaces together. This coefficient is very specific to the materials involved in the contacting surfaces. A rougher surface will have a higher coefficient and vice versa. Now, before moving ahead with the calculation and formulas, I would like to make you all aware with some terms involved in this concept. Let us say we want to push this box here on the surface and we have to push the object in such a way that it moves on a constant speed. The object has a mass and therefore there is a weight of the object which is acting downwards due to the force of gravity. So here the one representing the letter Z is the force of gravity. Then we have the normal force, which is the reaction of force pushing back from the ground to the upward direction. This is the normal force, which is the amount of force perpendicular to the surfaces that are in contact or the force holding the objects together, and it is represented by the letter capital N with an arrow on the top representing the direction. And the force of kinetic friction is the amount of force necessary to keep the two objects moving relative to each other. Here one is representing the opposing force or the force of friction, and one is representing the push that we are applying on the object. Now let us see the calculation of the coefficient of kinetic friction. To calculate the kinetic friction between two surfaces, we have to divide the force of kinetic friction divided by the normal force. So the formula turns out to be coefficient of kinetic friction equals to force of kinetic friction divided by the normal force of the object. Now let us see an example to make this even more clear. A bus is moving at a uniform speed with a normal force of 800 N. If the kinetic friction applied on this bus is 200 newtons, Then compute the coefficient of the kinetic friction involved here. So how do we solve it? For solving this, first of all let us check out the normal force, which is 800 Newton, and the kinetic friction is 200 Newton. Now we shall divide 200 by 800, which gives us 0.25. So the coefficient of kinetic friction involved here is 0.25. Now let us come to the coefficient of static friction. The maximum resistive force offered by the body against the applied force to continue its state of motion is called the coefficient of static friction. It is represented by the Greek alphabet mu s as static friction. Now, how do we calculate it? For its calculation, we have to divide the force of static friction divided by the force of the normal, and it is much similar to the calculation of kinetic friction. Now, let us see an example. For example, the normal force and the static frictional force of an object are 100 Newton and 130 Newton respectively. Find the coefficient of static friction. How do we solve it? First of all, the Newton is a Newton of normal is 100 Newton and the force of static friction is 130 Newton. Now we shall divide 130 by 100, which gives us 1.3. So the coefficient of static friction here is 1.3. I hope that this was clear to you. Thank you for watching.